Hi guys, today we're going to talk about arithmetic sequences and their connection with linear functions. Let's take a look at the first example. A plumber charges $90 for the first hour of work. $90 for the first hour of work. An additional $50 for every hour after that. So for the first hour of work, we pay $90, and then for every hour after that, we pay $50. The question is, write a list of an arithmetic sequence that shows the cost for the first 5 hours of the job. So the question is asking for a list of sequence. And a list of sequence starts with the first term, second term, third term, fourth term, and so on and so forth. So the first number that I'm going to put in this list is the cost for the first hour of the job, which is $90, as is mentioned in the question. Now, the cost for 2 hours is going to be the second term. And if the first hour is 90 and any additional hour after that is 50, that means I have to add 50 to 90 to get the cost of 2 hours. So that's 50 plus 90, which is 140. Now for the third hour, I'm going to have to pay $50 more. That means I'm going to have to add 50 to 140. I'm going to get 190. So 190 is the cost of 3 hours of work. Now for another hour, I need to pay $50 more. That means I have to add 190 and 50. That means I'm going to end up with 240. And for 5 hours, I need to pay $50 more. That means $290. So this is what I have, a list of sequence. The first term is the cost for the first hour. The second term is the cost for 2 hours. The third term is the cost for 3 hours. And every single time we're adding $50 to go to the next term. So that means we have an arithmetic sequence because we're adding a common difference every single time to go from one term to the next. So the second question says, identify the first term, A1, and the common difference, which is D. In this list, we can see that the first term is 90 and the common difference is 50 because that's the number that we keep adding every single time. Since this is a sequence, that means I can write an arithmetic sequence and or the nth term rule to describe the cost of the job. So the nth term rule, since this is an arithmetic sequence, is going to follow the format a sub n equals a sub 1 plus n minus 1 times d. And we said that anytime I need to write the nth term rule, I need to substitute a1 and d with values. So in this case, I have a1, which is 90, and I have d, which is 50. So now I can simplify. I can leave the nth term rule like that, or I can simplify by distributing 50 into the parentheses. So I'm going to get a sub n equals 90 plus 50 times n is 50n, and 50 times negative 1 is negative 50. Now to simplify this expression, I have like terms. 90 and negative 50 is 40. So I have 40 plus 50n. Now the question after that says, instead of having a list for a sequence, fill in the table for the cost, which is y, based on x number of hours. So for the first hour, we know we have 90. And for 2 hours, the cost is 140. For 3 hours, we know the cost is 190. 4 hours is 240, and 5 hours is 290. Now it says graph the table. So I have a graph here, and I'm trying to graph these values on my grid. I have 5 hours. That means I can set up the x axis for me to be able to graph. And now I need my y-axis to go from 0 to 290. So I am going to go by 20s. $160, $180, $200, I mean, and then $220, $240, $260, $280, and $300. So let's graph these points. We have 190. 190 is going to be here. 140. 140 is right here. 190 is going to be here. 240 is going to be here. And then 290 is going to be right here. So looking at the graph, I can see that this graph can be represented by a linear function. So it looks like a linear function. It says, write an equation that would determine the amount of money the plumber would charge for a job that lasts for n hours. So I have a linear function. I know that the linear function follow the format y equals mx plus b. And to find the linear function, I need m and I need b. I'm looking at the table to try and figure out these parameters. So looking at the tables, going from one y value to the next, I added 50. So 50 is going to be the slope. So the slope is 50. Now I need to find the y-intercept. Now I know that the y-intercept is the value when x equals 0. So that means I need to go one value before x equals 1 to find out what the y value is. So going from the y value of x equals 0 to the y value of x equals 1, I had to add 50 again. So I have to think, what number do I have in this spot? If I add 52, I'm going to get 90. And the answer is 90 minus 50, which is 40. So the answer for the y-intercept is going to be, or b is going to be 40. And the equation is y equals 50x plus 40. If we look at this equation, and if we look at the nth term rule of the arithmetic sequence, we can see that these two equations are almost the same. They have the same parameters. With the nth term rule, we have the 50 as the common difference, and we have 50 as the slope. So the question after that says, do you see the connection between the arithmetic sequence and the linear function? Blank in the arithmetic sequence equals blank in the linear function. And as you can see, the common difference in the arithmetic sequence is equal to the slope in the linear function. So I can say that the common difference, or D, is equal to M, or the slope, or the average rate of change in the linear function. You can order tickets for the local theater online. Their cost for the first ticket is $12 and $10 for each additional ticket after that. The first question says, write a list for an arithmetic sequence that shows the cost for the first 4 tickets. So that means we need the first term, second term, third term, and fourth term. So the first term represents the cost for 1 ticket, or the first ticket, which is 12. The second term represents the cost for 2 tickets. That means I need to pay $10 for $12 for the first ticket and $10 for the second ticket. That means 10 plus 12 is 22. And then for 3 tickets, I need to pay $10 extra. So that's 32. And 4 tickets, that means I need to pay $10 extra. That means 42. So that's the list, or the sequence represent the cost for the first 4 tickets. Identify the first term. The first term in this list is 12. The common difference, every single time we had to pay extra $10. So $10 is the common difference. And now the question is to write the nth term rule for a sequence that describes the cost. So the nth term rule follow the format a sub n equals a sub 1 plus n minus 1 times d. That means I need the first term and the common difference, which we already found. So we have a sub n equals 12 plus n minus 1 times 10. Now I can leave this like that, or I can distribute the 10. So I'm going to have a sub n equals 12 plus 10n minus 10. So a sub n equals, I have like terms, 12 minus 10 is 2 plus 10n. Now, the question is asking you to find the cost, which is y, for x number of tickets in a table. The first ticket, we know that it's 12. The cost for 2 tickets is 22. The cost for 3 tickets is 32, and 4 tickets is 42, which we already found. Now we need to graph this table. So I am going to set up my x-axis, 1, 2, 3, and 4. My x values need to go from 0 to 4. My y values need to go from 0 to 42. So I'm going to go by 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. And 2, 4, 6, 8, 10. And I think we have enough now. 112 is right here. 222 is right here. 332 is right here. And 442 is right here. So looking at this graph, I can see that I have a linear function, and this linear function goes with the format y equals mx plus b. That means I need to find m and b to find the equation. I can simply put the table in the calculator and hit the stats button to find the equation for me. Or I can see that the slope going from one y value to the next is by adding 10. That means the slope is 10. And the y-intercept is the y value for x equals 0. That means I need the value of y when x is equal to 0. Using the slope, I can see that the value that needs, or the y value for x equals 0 is 2, because when I add 10 to 2, I get 12. So 2 is the y-intercept. So looking at the linear equation and looking at the nth term rule, I can see that the parameters are the same. The slope in the linear equation matches the common difference in the arithmetic sequence. So let's talk about the difference between linear functions and arithmetic sequence so far. So clearly we can see that arithmetic sequences share many characteristics of linear functions. In fact, arithmetic sequences are examples of discrete linear functions. So basically, arithmetic sequences are called discrete linear functions. What does the word discrete mean? So far in Algebra 1, we have been working with a continuous variable. Continuous variable means a variable that takes all the real numbers between two extremes, or its extremes. And a discrete variable takes isolated or unconnected values between its extremes. This is not going to make sense to you unless exactly understand what the difference between the variables is. So when we talk about a continuous variable, we have examples like time. Time is continuous. Size is continuous. Water flow is continuous. When we talk about discrete variables, we're talking about number of tickets, where you don't have half a ticket. You don't need rationals to represent the variable. Number of people. We don't have half a person. So we don't need rationals to represent the number of people. Number of items. We don't talk about half an item. It's one item or two items or three items. So basically, with continuous variables, we take all real numbers to represent the variable, all real numbers. But for a discrete variable, we can represent the variable by natural numbers, 1, 2, 3, without the negative numbers, no rationals, or by whole numbers with 0. We can use the integers, negative numbers, and positive numbers without rationals. And these are numbers that disconnect. They're not continuous, like the real numbers. They're all connected together. That's why when the domain or range of a function is continuous, the function is called a continuous function. But when the domain and range are discrete, we call the function a discrete function. So if you look back at the first example, the the x values are the number of hours, and the y values are the money in dollars. So since we're talking about time for the x axis, time is continuous. You cannot just jump from an hour to 2 hours without going through the numbers in between 1 to 2. So that's why this is a continuous variable and the function is continuous. And when we have a continuous function, we use, or when we have a continuous variable, we use a continuous function or linear functions in this case. But if you look at the second example, we have the number of tickets and we have the cost for these tickets. And if you look at the variable, which is the number of tickets, this is not a continuous variable. We jump from 1 ticket to 2 tickets. We don't have half a ticket or 1/4 of a ticket. That's why the values jump from 1 to 2 to 3 to 4. Because these numbers or these dots are not continuous, they do not connect. This is called a discrete function, and it's best represented by an arithmetic sequence. So when we have a continuous variable or a continuous domain, we use linear functions. And when we have a discrete variable for the domain, we use an arithmetic sequence. But at the end, arithmetic sequences are discrete linear functions.